This is homework 49, solving systems of linear inequalities. Our first problem, which pair is the solution set for the system of equations? And they give us two equations. So x plus 2y is less than or equal to 6. Well, it's in standard form, so let's graph this by the intercept. So we've got an x-intercept of 6, and 2y is less than 6, so we have a y-intercept of 3. So that means we're going down 1 over 2, down 1 over 2, down 1 over 2, keep on doing that, up 1 over 2. So we've got a line that looks like this. Now we have the equal sign in our inequality, so I'm going to make a solid line here. And it's in standard form, so I can't use the whether or not we're eating the y or not, because it's not in slope-intercept form. But we can say use 0, 0 as our test point, so that would make our whole left side of our equation 0. So is 0 less than or equal to 6? And yes, 0 is less than or equal to 6. So we'd want to shade the bottom of this line. Let's do our other line. Our other line, negative x plus y less than 0. This is a little bit weird because we're at 0, and we'd have 0 and 0 as our y-intercept, and it would be tricky to show you. So let's solve this for y. What would we do? We'd add x to both sides. So we have y is less than x, right? So that now that's easy to see. Okay, it's 0, 0 is our x and y-intercept, right? Our y-intercept is 0. And we're going, our slope is 1, so that means we have a positive slope here. Now this one, we can use that trick where we see whether or not, because it's in slope-intercept form, it's not eating the y, so we shade the bottom of this line. So we'd shade the bottom right there. Okay. So also this doesn't have the equal sign, so this is a dashed line, not a solid line. So those are those two, that's the two lines. That's when you see those two equations, that's what we're thinking. And now the question is A, so is A, we'll say, is in blue here, negative 3, negative 1, negative 3, negative 1. Is that a solution? So we need to know if we didn't shade. So our solution, right? What part is below both of these? Well, we'd shade everything in here is below the solid line and below the dashed line. So we can see pretty quickly negative 3, negative 1 isn't a solution. How about B? 0, 3. Well, 0, 3, that's on, 0, 3 is on that solid line, right? But it's not above, or it's not below that dashed line. So this one's going to be, that one looks like it's going to be a no too. 0, 0. I shouldn't do that in that color pen. 0, 0 right here. Well, that's on the dashed line, so that automatically can't be a solution because it's on the dashed line, so that one's a no. And D2, 1, do in yellow, 2, 1, right there, we're going to say yes. That looks like a solution. So now algebraically, let's do this algebraically. Algebraically, we need to take these equations. So our top equation, x plus 2y is less than or equal to 6, and we're going to substitute in 2, 1 and see if that works. So 2x is 2, y is 1, 2, and 2 times 1 is 2. Is that less than or equal to 6? Is 4 less than or equal to 6? Yes, that's true. So now let's go to that next equation. Our second equation was negative x plus y. Is that less than or equal to 0? So we'll plug in our 2, 1 again, 2 and 1. So is negative 2 plus 1, is that less than or equal to 0? Is negative 1 less than 0? Yes, negative 1 is less than 0, so it works. We just proved that that's a solution. Now, what would happen on all the rest of these? On all the rest of these, it would end up not being a solution. I don't want to go through every single one of those to get to that. We'll do it on this next one, because I don't really feel like graphing this next one. So let's get some practice graphing. Anyway, we need practice. Let's do it. Don't let me talk you out of it. So we've got our top equation, x minus 1 is greater than 1. I don't like that. We're going to change this. X minus 1 greater than 1. Let's move that over. X, add 1 to both sides, is x greater than 2. That looks like a better equation. So, well, what do we notice about this? There's no y value here, right? So no y value, that means we've got a vertical line. No equal sign, so we're going to have a dashed vertical line at 2, right? And we're talking about wanting to be, we're eating the x, so x is greater than 2, so what side would be greater than 2? It would be the right side we'd shade on. Our other equation, y is less than 2x minus 1, y-intercept is at negative 1, slope is 2, up 2 over 1, down 2 left 1. Do I have the equal sign? No, so that's a dashed line as well. And this is in slope-intercept form, and we're not eating the y, so we say we're going to shade the bottom of this line as well. And so now where would we be shading if we wanted to be below this dashed line and below the, or actually it would be above this x is greater than 2? Well, to the right of that line, that would be everything over here. Right? So our points, negative 2, negative 4. Negative 2, negative 4, looks like we're just not even close. 0, negative 2, 0, negative 2. That doesn't look like that's going to work either. Negative 1, 1. Negative 1, 1. I say no to that. And 2, 2. I say no to that as well. Did I make a mistake somewhere? Are they all no's? 2x minus 1, 2, 2. Negative 1, 1, negative 2, negative 4, negative 2, negative 4, 2, 2. Yeah, they're all no's there. So let's do one of them. Let's do 2, 2. So we've got x minus 1 greater than 1, and we'll plug in a 2 for x. And there is no y to plug in, so is 2 minus 1 is 1 greater than 1, and that's why that was a no, even though it's on this line here, right? It's on a dashed line. So it looks like it should be a solution, but it's not. Alright, graphing some more inequalities. Y-intercept is -3. Slope is -2. Don't have the equal sign, so it's dashed line. We're eating the y, so we're going to shade the top. So I'll put a little arrow on the top. Our next one. Y-intercept is at 2. Slope is -2. Down 2 over 1. Down 2 over 1. Down 2 over 1. Up 2. Left 1. We have the equal sign, so we'll do a solid line. And we're eating the rest of it, so we're going to shade the bottom. So what section are we talking about? We're talking about the section in between the blue line and the green line, and including the green line because it has the equal symbol, not including the blue line because it has a dashed line. It does not have the equal symbol. Next one, y-intercept is at -3. Slope is 2. Don't have the equal sign, so we'll do a dashed line. We're eating the y, so we'd shade on top, so I'd put a little arrow there to remind me that I'll shade the top of that line. Our next equation, y-intercept is at 2. Slope is down 1, right 2. Down 1, right 2. Or up 1, left 2. Still don't have the equal sign, so dashed line again. This time we're eating the y, or again we're going to eat the y. So the top of this line would be the top. Think about rain coming down, right? Rain's always going to hit the top of your roof. It's not going to hit the bottom of your roof, so the top would always be where the rain hits. So what section would that be? Above the blue line and above the green line, not including either of those because they're both dashed. 3. Y-intercept is -1. Slope is 2. Solid line. We have the equal symbol. We're eating the y. Shade on top. Next one, y-intercept is 3. Slope is -2. Don't have the equal sign. Dashed line. And we're not eating the y, so we're going to shade on bottom. The bottom. So what's above the blue line and below the green line? That would be everything over here, and including that portion of the blue line, but not anything on that green line because it's dashed. Next one. Well, if we solve for our x-intercept, we'd get a half, right? So I don't want to do that. I don't want to throw people off. So if we move that 2x over to the other side by subtracting it, we get y is greater than -2x plus 1. So what's our y-intercept is 1, slope is -2. Dash line, don't have the equal symbol. Next line, same idea here. Move the x over. This would make -y is less than, we're subtracting x, right? Plus 2, but now to make that y positive, we need to multiply by -1 or divide by -1. Either way, let's say we multiply the entire equation by -1. we get y. When we multiply by a negative, make sure we reverse our inequality symbol. And now we're changing the sign of everything. So our y-intercept is -2, and our slope is up 1 over 1. Slope is 1. And we don't have the equal sign, so it's a dashed line as well. And we're eating the y, so we're on top of this line. And so, oh, I forgot to say whether or not we're on top or on bottom of the blue line. We're eating the y again, so we're on top of the blue line. And so that section is right there. Not including either of those dashed lines. 5. Let's solve this. Let's just practice solving this for y. So we're subtracting 2x. -3y greater than or equal to -2x minus 3. Divide by -3. The first thing we want to do is reverse that inequality symbol. Y is less than or equal to 2 negatives make a positive, and 2 negatives make a positive. So our y-intercept is 1. Our slope is up 2, right 3. Down 2, left 3. Down 2, left 3, somewhere over here. And we're going to be using a solid line. And we're not eating the y. Y is less than, so we want to shade the bottom of that line. Our next line, 2x minus y is greater than 3. Subtract 2x. -y is greater than -2x plus 3. Multiply this whole thing by -1. So y, change our inequality around. Y is less than 2x minus 3. Y-intercept is -3. Slope is 2. Don't have the equal symbol, so we're going to use a dashed line. And we're eating the rest of the equation, so we shade the bottom. So what's below both of these lines? Right there. And our last problem, let's use the x and y intercepts. Why did I choose that? Because I'm not going to have fractions. So our x-intercept is going to be at -6 out here, and our y-intercept will be at +2 right here. So that means we're going up 1 over 3, up 1 over 3, and we're using a dashed line. Now, I didn't put this in slope-intercept form, so we need to do our 0 test, right? Is 0 greater than -6? Yes, 0 is greater than -6. Should we shade the yes side, right? We're doing 0, 0, plugging in 0, 0. That makes our whole left side 0. So yes, 0 is greater than -6. All right, our next one, well, 2 doesn't go into 3. I don't want to put 3 halves. That's 1 1/2. I don't want to do that. So let's solve this for, let's solve that for y. 2x minus y is greater than 3. If we subtract 2x, we get -y is greater than -2x plus 3. Divide everything by -1. I also could have showed that by multiplying by -1. Reverse our inequality. 2 negatives make a positive. A negative and a positive makes a negative. Y-intercept is -3. Slope is 2. Don't have the equal sign, dashed line. We're eating the rest of the equation, so we're shading the bottom. So what's below both of those lines? This section over here.